Now we'll see how to search for the data sets. First let me search for some DEM image. You can see some data set of NASA SRTM detailed elevation. You can go and see the description here and the bands, and the elevation band, minimum and maximum values, resolution 30 meters. You can go and simply click import. So here satellite data will be stored in an image variable. And you can simply rename the sets DEM. Okay, then you can simply write print DEM. So what it gets printed, you can see here in the console. This is just an image with one band elevation. So if you can add this one also here, when you add this DEM image, it will be shown in the bottom part of the window. Command to add is map.add. If you don't know the full command, you can press the control space bar and it will show what are the functions available with map.add. One is map.add item. This is simply a small this is for normally for different thing. This is what we are going to use, map.add layer. Here you can see this is a function with several parameters, so arguments. One is the E object, means next is the visualizations, is params, name, shown, opacity. These are the arguments which is accepted by this function add layer. So you can see what are those arguments. These params are the visualization parameters. That means we want to show some particular bands of the image. Then you can specify what value you want to see. And you have to specify the minimum and maximum values of that band. Those things we can mention within visualization params. That is the second argument. So that will be given as a dictionary. And this one is the name of the layer. This I will show you now. So this one is the function we are going to use. The first one is the object, E object. So this one is the E object, DEM. This is the image, DEM. Then next one is the visualization parameter. So here you will see minimum of 0, maximum of 8000. Okay, then we can give the name. Name is the name of the layer. Here we are going to give the name of the layer as DEM. You see this DEM is caps and this is small. This is a string. This is an object, an object, E object. So if you add here, what you will see, this will give the DEM image of the whole planet. So this is South America, Africa, everywhere it will show the DEM image. And this is actually running in the server. That's why this is loaded very fastly. You should also have a good internet connection also for this one. Then if you see the inspector tab here and simply click somewhere, you can see the value of that here, elevation 6595, 6598 here. Similarly anywhere else you click you get another value for the elevation. Okay, so like that we can inspect whatever the values of the image that what we have added in this layer. So another thing is can also, this is the vis params argument for this function. This is given in this is given as sort of dictionary. So here you can also add some color also, like palette. If you give palette, that is the key, the value yellow, comma red, it will show a yellow red color image. Earlier it was grayscale image. Now it will show, oh sorry, yellow spelling is wrong, by yellow. If something is wrong, it will show that here layer error found yellow, that is wrong, that's why. Okay, you run this one, you can see a yellow red color image here. want to see another, like another data, global water. This surface water. Here you can see this discussion bands. You have only one band, but with name occurrence. Show the frequency with which water is present from 0 to 100%. So we can know the areas covered by water. So here I imported that one. We will rename as water and simply add to this one map. Dot add again control space bar. Will show you the functions. So I want to add this water as a layer. So add map. The first argument is the object. So that is the water object here, water. E object is water. Then visualization params. I want to see the occurrence. You can see here. Here only there was one elevation, only one bandwidth elevation. Here you can see bands with occurrence. There are several other properties. We want to see only the occurrence one. So in the visualization parameter we can specify bands as occurrence. Make sure your spelling is correct, otherwise it will show error. Then minimum, maximum, I know it, occurrence, and I can give you some palette. Light blue, comma blue. Then the name of the layer, water. It should be added here. Already layer dem is added here because we have given this command. This layer is added here and it can be shown here. Now there will be two layers when you run this command. One will be dem, another will be water. This is water. So if I run, I don't need this one, this color now here. Simply I only need this one, gray image for dem. That way I have deleted the palette. Run. You see here there are two layers, water and dem. First one is the dem which was loaded, then this is the water. So if you go and click the inspector tool and just inspect any values here, it will show both the elevation dem and water also, elevation and water. So if you want to calculate some slope from this dem image, what you can use, variable slope equal to, there is this earth engine object like e dot terrain dot slope. This is the function in for earth engine, and we will just pass dem here. Then it will automatically calculate the slope for the whole planet, and you can add that slope map in here. It's like add layer. Okay, first one is slope. So this one is what we have calculated, this slope using this e dot terrain function, dot slope function. So this also can be added to the map as a layer. So I will add map slope. In the slope I will show slope from minimum 0 to maximum 60-degree slope. Okay, then palette also I will show like yellow to red. So minimum 0 slope will be yellow, maximum slope will be red. Then the third argument for this add layer function is the name of the layer. So I will use slope layer. These are different slope. This slope is different. This is the object of the earth engine object. This is the name of this layer. Those are different. That's a given different. three layers here: water, depth, slope. So slope I have loaded first, that's why slope was calculated first, then it is the water bands. So if you put search here, you can get three values. Slope is 0, there is water there, elevation, and open the 197% water is there. We got plus here, there is water 46%, slope is 5 degrees. Okay, like that you can see the different satellite images here, and now we'll see how to load a Landsat image and do some basic band operations. First of all, let me search for the Landsat data. Landsat 8 TOA. This one is the Landsat data you are going to use. You can see the bands. There are total 12 bands. Simply click import and rename it as L8. You see the size of this image. You press run. You can see that there are around 12,76,035 images. I don't need to load all these images at once, since it will take a lot of time and lot of data. So what I am going to do is just filter out the images according to some date range and according to location and like cloud cover, etc. So how to do that? Simply type in a variable filtered, then L8 dot filter is the function filter date. Here you have to give the date as string, year, month format. So from I am getting the date from 2020 June 1 to 2020 December 30. Now if I check the size of this image, there are only 87,340 images. So you can also filter by the area of interest. How to do that? Simply zoom into the area where you want to get the images. For example, I will be just zoom into the southern part of India, and you will add a geometry. Like I press this button and simply place it somewhere here. Okay, then this will be imported as a geometry here. Simply rename it as area of interest and type in dot, type in the next line, filter bounds AOI. Now you can simply load this. Instead of doing this first, I will just load this first. How to load the image? We'll type in the parameters. This one we need to see a true color image of this image. So the true color, you can see the band combinations are V4, V3 and V2. V4 is red, V3 is green, V2 is blue. So I will give this visualization parameter for bands as a list of the bands. In the same order. V4 will be first, V3 will be next one, V2 will be next one. I can also specify the minimum maximum value. I will just put a random value here. It actually ranges from 0 to 1. So minimum maximum I will put something around 0.0 to 0.5. Then the name of the layer in a string. So this is a true color image. And press run. You can see in this panel, layers have been added as true color. You can see this one. There are around 87,340 images for the whole planet in this date range from July to December 2020. So what I need is only I want to just again filter to the area of interest. So what I will do is I will type in this command to this separate dot. I will type in this command filter bounds dot AOI, what we have given this earlier. So again, if I run, you can see there will be a few images, 11 images. Those 11 images have been loaded here. So if I just move it somewhere around here and again press run, you can see 24 images. Earlier it was 11 images. Since this point, you can see this point is intersecting both the areas, both the satellite imageries. That's why only this the area which is intersected by this our polygon. That polygon which is maybe a point or then maybe a polygon. So the area which will be intersected by this point or polygon, only that images will be displayed. If I just move it here, you will not get this image, the left one. You will see only 11 images are there. If I move it where both the images will be intersected, so and if you press run, there will be more images, 24 images, and that is what is loaded here. You can see there are many clouds here. What I will do, I am going to simply press filter, and I will just display the median values here. Median values means I think this is a 24 images. Maybe the first 2 images have been shown here. So below this there may be 12 images, and below this another 12 images. That's why showing 24 images. So if I want, means every images are like in a stack, 12 images in a stack, another 12 images in a stack. So from this stack I will get a median pixel value. So So what this median pixel value will do, I will show you. Now you can see there are many clouds in this part and this part. If I simply press median, simply type median and press run, you see most of the clouds are filtered out, mostly in the part of Tamil Nadu. And the Tamil Nadu for this date range from July to December 2020, mostly it is cloud free. That is why the median value is giving cloud free images. Means the median means from the median of this 12 images, and here also you can see median is not showing that much cloud free. It's mostly in the Kerala part, mostly in the state range it is cloud covered. That is why the median value is also showing some cloud cover. If it was not cloud covered in this date range, so it also might have shown cloud free images, but here in the Kerala part you can see mostly it is rainy, so that is maybe the reason it is showing clouds. So another way of filtering the clouds is simply by, now I will simply remove this first and I will show you this one, how to filter by cloud free, how to get cloud free images by filtering using metadata. Metadata means if you go here and if you see the image properties, what and all these are there, those are the metadata, cloud cover, land, everything. So I will filter it by this property, cloud cover. This is the property, cloud cover, cloud underscore cover, and the percentage I will filter it by less than 10% cloud cover, like that. So what I will do, the function is filter metadata. Filter metadata. And what this takes is the name of the property, that is the cloud cover, and then the operator cloud cover less than value 10. So I will just type in like that, so I will get the images with less than 10% cloud cover. So I will type in here as a string cloud cover, another string less than 10. Now if I run this one, I may not get 24 images, maybe 3 or 4. Okay, there's only one image. So I need more images. What I will do, I will change the date range and press run. I have 6 images. Okay, there are some clouds here also. So 6 means I may be 3 here and 3 here. So if I take another median for this image also, some clouds have been removed, so I can see this true color image with only very few clouds here. So now we'll see how to do some band calculations. For example, this NDVI, how to do this NDVI. I will just filter this one. So in order to do NDVI first, and this NDVI operation, NDVI band calculation can be done for a single band, then you can apply for this multiple images. Oh, I forgot to mention this one. This Landsat is an image collection. This is not an image. In the earlier we have seen some DEM images, surface, global surface water, satellite images. Those are only images that was not collected during any time period. So here this Landsat have been collected during several years. So that way there are a lot of images, and therefore it is called as image collection. So in a collection you can do directly the NDVI calculation. you can do for a single image. Then you can apply some logic to um, loop over this to calculate NDVI for this whole collection using some other logic. So first I will show you how to calculate for a single image. So in order this, now we have 6 images here. Even though here it is showing only the median value, already 6 images are there in this collection after filtering. So if I want to get only one image, I will simply press dot first. I will get only one image. So if you just remove this one and now run this one, you will get only one image. Now this is the image. So in this image, first we will calculate the NDVI, then we will apply for the rest. There are 6 images here. So I will just calculate for this first one, then I will apply for the other 5 images NDVI calculation. So how to do that is simply, there are 2 methods. First I will show you the first method. Plus where for NDVI equal to filtered. Now it is filtered. Object has only one image. So I will take filtered dot. There is an inbuilt function called normalized difference. So this will automatically calculate the NDVI formula for you. NDVI formula is B5 minus B4 divided by B5 plus B4. So that will give the NDVI index. So I will just give those as a list. B5 comma B4. And I will simply display this one. Map dot add layer. I want to add this NDVI. Then you can give the min max point to something like that. And then you can give the name of the layer as NDVI. Press run. We have 2 images, 2 layers. One is tubular and next one is NDVI. There was some problem with the connection. Again press run. There are 2 layers, 2 color image, and then this one is the NDVI. This is the true color. Okay. So we have got an NDVI image here, and you press the inspector button and press here somewhere. We can see the NDVI value here 0.628. You can change the min max if you change it to some other 0.5. Press run. This is little more clearer, better. So here, this is the first method. Now there are also other method like for example, you have, this is a simple band calculation, B5 minus B4 plus B5 plus B4. So here if you have some other complex equations, so this method will be better. So what I will do is, I will first select out the bands. So I want the B5 band. How to select this? Go to the image. This is the single image filtered. Dot select, and I will simply select the B5 band. So the B5 band will be selected will be stored in this variable B5 band. Similarly for B4 band, we'll do the same thing. Filtered dot select B4. After that, we will do the calculation for NDVA or NDVA. This one I will give it as 2 because already I have NDVA variable here. So you will want to repeat that one. NDVA2, then you have to calculate it for the single image filter dot what you will type expression. What this expression function will do? This will take in an expression like a formula. We can give it as B5 minus B4 directly. B5 minus B4 by B5 plus B4. This will be given as a string, and after that the second argument for this function will be the map argument. Map means you can see here. Press control space. First is the expression. That means you see x equal to a plus b. This is the expression, for example. So in this example, it is b5 minus b4 plus b5 plus b4. b5 minus b4 divided by b5 plus b4. So here it will take this expression. Then a map means what the means bands we are going to map with this expression. So expression is b5 minus b4 plus b by d divided by b5 plus b4. So b5 will be mapped to this variable b5 band, which is having the with b5 band values, and similarly b4 will be mapped to this variable which is having the value for b4 band. So I will be first of all giving the expression as a string b5 minus b4 b5 minus b4 by b5 plus b4. This is the expression. Next is the map. How to map this one? Map will be set as a dictionary. So the string b5 I will map to the b5 band which has the value for the b5. So this b5 in this expression now, this b5 will be mapped to b5 band. The value will be stored here. So similarly b4 will be mapped to b4 band. Okay, so this is how we will do the calculation for NDVA to second. This is the second method. So simply you see this, we will simply put an NDVA2 instead of the NDVA1. We will do this NDVA2 thus using the second method. What and how we will get the result, we can see. You can go to the NDVA2. This is the okay, I have to rename also. This was NDV2. This is the NDV2 image before, means the second, using the second method. So you get the similar results. And now we have calculated for a single image. We want to calculate for multiple images. So I will use a function known as map function. Before using that function, I will be using another function so that this map function accepts another function. So if you first you have to define a function to calculate this NDVA. So with this function which we will define for calculating NDVA, that will be passed to this map function. So this is a function within a function. So first of all I will define this function first. We have seen function to add two numbers, so it will be easier to add two numbers by calling this function in the other part of this script, in the later part anywhere in the script. So similarly, if you want to do that function, we will call this for NDVA. First I will remove this first method. This is also having the same variable NDVA, make confusion, that's why I will remove this one. Then this is for the function, defining a function. I will simply write here. Define function for calculating NDVA. So here variable NDVA equal to, how to give the function. First of all, we have to give the variable for storing the return value from the function. So this is how this method function will take some random images and will return something. Now I don't know what to return. So what we will return is the NDVA what you will calculate. So how this will calculate, we have already described this method. I will simply copy paste it here. Okay, then what I will do, I will put this one also. Okay, now this is a function for calculating the NDVA. So if you want to see this one, this is a function. So if you want to see this again for a single image again, so what I will do is I will store again another variable NDVA visualization equal to, I will simply call this function NDVA. This is the name of the function NDVA, this one, and I will pass in the image. This is the image. Already we have image here filtered. This is for a single image. So first of all I will pass a single image filtered. So I will call this function here, and this now this function will return this NDVA2, and that will be stored in this variable. So if I want to visualize that one, I will simply write NDVA vis and I will press run. Okay, null object as a layer. Okay, I got there because this function what you have defined here, now it is not returning anything. That is the problem. So I have to return this NDVA to what you have calculated. Okay, that is why the problem was coming. So now if I run this print NDVA, I will get an image with one band. So band is usually given as B5. This is the NDVA calculated. There is some naming convention here, that it is coming as B5. I will show I have to change that band name. Here if you press rename and give it as NDVI, and again press run. You see this NDVA. This is only a single band, one image is a single band that we have returned from this function. So what I need is I want to put this as a band within all this feature collection, within this feature collection, which is this image L8. We have single image, one image only, so I can also add like here. So here you can actually one more error is there. Since this I have defined this function with passing an image here, so same should be passed here. Instead of filtered, it should be image, but filtered is also okay since only one image is present in that. Therefore, no error has come. Otherwise, it will lead to an error. So you have to replace that with image only, not filtered. Whatever the image we are passing in this function, that should be selected. From that image, the band should be selected. Then from that image, this expression should be run. So I have replaced it with image only. So that is the correct method. So here we can pass this filtered, what we have filtered here, the one image here filtered, only one image is there in the variable filtered. So that we are passing to this function. Function name is ndvi. So ndvi will accept this image filtered with one image, and that will go to this function, and it will select the bands V5 and V4 and calculate the ndvi and return the ndvi, and that ndvi is being printed out here. If I this one also, if I uncomment it, and run, I will get the ndvi here itself. Okay, so this is for a single image. Now we have to calculate it for multiple images. Before that, I can add this as a single band to the image filtered. So how to add that is return whatever we are passing this filtered here in this argument image img. So in the same filtered, I will add a band ndvi2. So this is function to add the bands. Add bands. This is the function. So ndvi2 will be added as a band in this filtered image. So filtered image is having already 12 bands, b1 to b11 plus some other band, and this one will be the 13th band which will be added to this image, single image filtered, this one. So if I run now and see, you can see the image is here. There are 13 bands, 13 elements. You see here, the last element is the ndva, last band is the ndva. Okay, so here we can just tweak the min-max values and custom indeed percent apply to show a dark image maybe. Okay, this is the ndv image. So likewise 0.05 to 0.18. So this is for a single image. Now I will show you how to do this, how to pass this function in ndva, custom defined function. That is, we have defined this function, custom defined function, to an inbuilt function called as map. So what that map function will do, that map function will apply this function to a collection of images. Now this is a single image. I will just make a collection by removing this one. Here it will be, yes, you can, we'll just see the size. It will be 6 images maybe. Okay. There will be 6 images. This I will deal with now. So if I do this one, I will just comment it out. Now if I see the map function, how to map over a series of images. So to make sure I have not defined 1dv2 somewhere else. No. Okay, what I will do is we will go to the filtered image. Earlier it was one image, now it is 6 images. So it is a collection. So I am doing the map function for this image collection. So the map function will accept this another function, which is the custom defined function ndva. So I will pass this ndva. So now this one will map this function over this feature collection filtered over the 6 images. In each image it will apply this function and return the ndva bands using the and store in this one variable. Now if you don't need this one, this one also I will leave. So let's simply put ndva2 press run. You see it has done the calculation for all the 6 images. There are 6 images in the filtered collection. For all the 6 images it has done this ndva calculation. So I can also take the tweak the value here, custom values, 98% of the values, apply, close. Can also take the median here, median value of the ndva, run. That will remove the nodes also. This is ndva2. Now this is how we use a map function to map to calculate or a set of images. So now again what you can see is how to export these images. So you can also do the palettes also, like here if you view palette, no, not palette, first okay, here I have this one is actually an image collection. You see, wait a minute, ndva2, there was some error because it was not showing the exact ndva image here. It was showing only, you see, this is image collection with feature. Feature means there are 6 images. This is image 1, image 2, and each image having 13 bands. You can plus here 13 elements, so 13 bands. 1 to 13 is, so it is beginning from 0. So this is the 13th one in DVA. So actually I have not given the visualization parameter for this. I have not mentioned the bands which I want to visualize. I simply put min and max. I actually have to put this bands also. Bands, the string ndvi. This one is this is a string. So this band I want to visualize. So I was visualizing some other thing. So if I now run this one, this is the ndva image. For this 6 images are there. For the 6 images, this is the ndva. So if I take it as median now, that also will give this median value of this ndva. Okay, so I don't need the median value will be okay. Then if I want to export this one, you can export. There is a means, you can see, to export images, Google Earth Engine. Simply click here. The code will be already here. You can get an example from this one. Export an image in your Drive, Google Drive account. This is the command. So you will simply copy this one to our script. The image is you want to take the NDVI2. For this one more thing, I can also use a color also, like not in this one, in this one. Palette, light green to green. Brush, will comment it now here. Just I will delete it now here. Let's run. What is this one? NDV image here. No, I don't need this truth color which will contain. Just delete this one. NDV2. Okay, then if I press this one image, NDVI2, relabel give this 100. Now this geometry I want only a part of this image, so I can, instead of this single point, I can take this first of all you have to lock this one, otherwise it will be added as a picture geometry collection. In the same collection there will be point and polygon. So if I lock this one and then add this one, I need a small portion like this much of this. So this will be imported here as geometry. So that geometry will be taken here, region geometry. So if I now press run, you can see in the taskbar this has been exported. And it has not been exported, it will be exported now after running here. It will take some time. Okay, now you see there is an error. You see there is some error here. You can see this error, image flipped around and scale, expected type image, actual type image collection. Actually in this command export dot image to drive, what it takes only is an image, not an image collection. Here now this is an image collection ndv_2. So we have to make it as an image. So simply you can type in the command median. So it will take only the median value of the image collection. There are 6 images. So from the 6 images it will only take the median value and it will return only a single image. So if you go and check and if you simply run this one, Actually there are one more error. Since this image collection is having the bands, 13 bands, and every band has a different data type. One band has a different data type. This VQA band has a data type unsigned integer 16. Rest of the bands are having the float data type. So if the data types are differing, then also it will create a problem while exporting. So we have to make it either make this as an float. Otherwise you can simply select this only the NDVA band also, that is a float one. So we can simply select NDVA. Before that, if you please run, and you can see there is only now one image because we have given median of this one. So we have calculated only one image, and that image is being exported, and they have only selected one band. So this image is having only one band NDVA with float data type. And now it is shown in the taskbar. You can simply press run, accept the default with exporting by 100-meter resolution. Press run. It will be running here. You can see the gear icon here. So likewise, if you want to know what are the different functions or what is the command to export an image to drive, you can simply Google it and you will get the code in your in your Google documentation. Simply you can copy paste the code whatever it is and simply tweak according to your needs. And apart from that, since there was some error, I have actually saved the script, like you have saved this one as tutorial here. If you click save, it will be saved as and give some name for your script, like I have given here for tutorial. It will be saved in your account. So here are there are other two codes for land use classification using machine learning algorithms. And if you likewise, if you have any doubt regarding writing programs for writing the regarding the syntax of JavaScript and all, you can simply go to the Google documentation and see there how we can write the syntax. We will wait for the image to export. So if we have given a scale of 30 meters, it will take much more time to export because the image size will be larger. So that's why I have given here 100. So this image will be exported as in gray scale only, not in this green color. There are other functions also so to export the images, as you can see in this bottom window, like we have this green color. So there are other functions like dot visualize function is there. If you use that one, whatever we see in the window, this bottom panel, so that color will be exported as to Google Drive. Here I have not added this one, that you can tweak it later also. So it's taking a bit of time here. Okay, it has been exported. If you can see, you can open in Drive. Simply click that to download a small file only. This is the grayscale NDV image we have exported to Google Drive. This is how we can import a satellite image, do some basic analysis, and finally export the images to Google Drive. You can use these images to in GIS software also to add legends, title and all. There are other methods to add legends, title in the Google Earth Engine itself, but that will require a few more lines of code, which is beyond the scope of this video. One good thing with coding is that you can just calculate the NDVA for the whole planet also. Then you can choose the area of interest, like this you can draw any polygon and you can also bring in your shape files of different states or districts like that, and accordingly you can generate you can export the NDV of that particular area of interest. And another thing is that you can also this image is of 30-meter resolution. If you get some other satellite images of more resolution with this bands, you can simply import that image instead of this Landsat 8, and you can do some minor tweaks and calculate the NDV for a better resolution. If at all this is, if it is available, such satellite data is available, you can just import that one here, like we imported the Landsat 8, and simply use the rest part of the code to do the NDV calculation. So this is all for this video. Thank you.